Okay, good evening. This is Professor David J. De Los Reyes. Okay. My topic for this discussion will be it's still college algebra, and this will now be lesson number 72. We are running smooth on college algebra. We are now on lesson number 72, and the title of the topic is literal equations. Okay, let's proceed. Long video format discussion. This is college algebra, lesson number 72. The title of the topic is literal equations. What is a literal equation? An equation that has more than one variable. An equation that has more than one variable. An example of this one is capital letter C is equal to 2 pi r small letter r. This capital letter C represents the circumference of a circle. Okay, and this small letter r represents the radius of the circle. If we try to compute the circumference of a circle, this is a circle, right? If we try to take the circumference, it will be by using the literal equation circumference is equal to 2 pi r. So a good example of a literal equation is actually circumference is equal to 2 pi r. Okay, literal equation. Literal equation in real life has so many applications because when we reach the so-called study of differential equation, in the formulation of the equations needed in the so-called maximization and minimization of anything under differential calculus, we need the relation literal equations. An example of a literal equation is circumference is equal to 2 pi r, or the area of a circle may be pi r square, or the area of a rectangle will be equal to the product of the length times width, something like that. So a literal equation is an equation that has more than one variable. Okay, we assume for the meantime that the circumference is variable, the radius is variable, so it involves two variables, so we could say that circumference is equal to 2 pi r is a literal equation. Okay. In real life, it has so many applications. Okay, let's proceed. How to solve a literal equation? It's an easy thing, right? It's just like we are given the relation on an equation involving x and y. If the problem is asking what will be y as a function of x, we could do that. Or the reverse of that, what will be x equal to a function of y. Still, we could do that. And that's the solution of a lateral equation. Number one, write an equivalent expansion. Meaning to say, if we are given a literal equation, to find y as a function of x or x as a function of y, first rule is to expand first, expansion. So we will be using the so-called distributive law under algebra. The past lessons we had finished. And the next one, the solved variable is isolated on one side of the equation, meaning to say the variable which is required, okay, is isolated. It is placed always on the left-hand side. That's the term isolated. We place it always on the left-hand side, and all the other variables containing the literal equation will be on the right-hand side. That's the meaning of this. Okay, let's try to proceed with an example problem so we could visualize what I call this literal equation. It is important. I've been teaching differential and integral calculus plus advanced mathematics, and in the formulation of the equations needed in the so-called maximization or minimization, we use literal equations there involving the formulas for volumes, area, circumference, right? Length of arc. Those are all literal equations. Okay, let's proceed with an example problem, still involving x and y. Example number one. Solve the literal equation for y. The given literal equation is, I will try to read the literal equation. For Open bracket. 2x minus 3 multiplied by the quantity x plus 2y, close quantity, close bracket, and this should be equal to 0. Oh, it's a little bit complicated because the given literal equation involves a quantity and open and close bracket. So we will be using PIMDAS maybe. There is a sequence of operations that should be followed. But I think the solution here is just straightforward. Solution. We'll bring down 4. Well, what you call this will expand first the one with the quantity. That's why the term here expansion, right? Don't touch this 2x here. It is alone, right? So 4 open bracket, 2x, we didn't touch it, minus, okay? The quantity, the product of x plus 2y, okay? So if we try to expand this one now, minus 3 times x will be negative 3x. Minus 3 times a positive 2y, a minus and a plus will be minus 6y. 3 times 2 will be 6, multiplied by y, close bracket, and this should be equal to 0. Right? Oh, that's the so-called expansion. Right? Oh, what will be next? Combine similar terms. 2x and 3x are similar. This is plus 2, this is minus 3, so it will be, the overall sign will be negative because the negative value is higher. This should be negative x. Okay. Minus 6y, it's alone. Minus 6y, close bracket, and this should be equal to 0. Okay. This 4 here is to be multiplied with the bracket thing again. So again, we expand. Again, still expansion, right? So 4 times minus x will be negative 4x. 4 times negative 6y will be negative 24y, and this should be equal to 0. Okay, I will try to rearrange. I will put first y, the one we are looking for. So I will write this one ahead. This is minus 24y. It will be followed by minus 4x. Okay, and I want this negative 24y on the left hand side to be alone. So I want to eliminate this negative 4x here. And to eliminate this negative 4x, I must have add up a value here. That's when we add it, it will cancel out. Okay, so if this is negative 4x, the enemy of negative 4x is plus 4x. Okay, so we add 4x on the left hand side, and this should be equal to 0. Also, we add 4x on the right hand side. This is plus 4x, plus 4x. We didn't change the value of the equation. And after the addition of 4x, this one here cancels with this. So the variable we are looking for is now alone on the left hand side, but it got a coefficient. Don't bother with the coefficient. Negative 24y equal to 0 plus 4x is just 4x, right? We are to solve for y as a function of x. Okay, so we must have to eliminate this negative 24 here. So dividing both sides by negative 24, right? What you will do on the left, do it on the right. So this negative 24 cancel with this. And negative of negative is plus now. Left hand side is y, the one we are looking for. And for the right hand side, 4 over negative 124 is actually negative 16 multiplied by x. And this will be our answer. Okay? We are to solve for y as a function of x from the given literal equation. Okay? Y is equal to negative 16 times x. That will be the answer for this problem here. Simple, right? Next one. Am I still on camera? Solve the literal equation for y. We are given the literal equation, a little bit complicated. It involves quantity and brackets. So I will try to read it. Negative 3, open bracket. Okay, the inside is 2 times the quantity x plus 5y minus, okay, open quantity x minus y, close quantity, close bracket, and this should be equal to 1. We are asked to solve for y in terms of x. Right? Y as a function of x. Okay? It's a literal equation. Solution. So this is minus 3. Under PIMDAS, we should what call this, simplify the terms under the so-called parentheses, right? Parentheses or quantity. If we try to expand this one, it will not affect this value here. So we can proceed with expansion of this and at the same time expand this, right? So minus 3, 2 times x will be 2x, 2 times 5y will be 10y, and minus 1 times x will be negative x, okay? So we are not following a sequence of order here. We what do you call this? We simplify it as it is. It is in sequence already. Minus 1 times minus y will be plus y, close bracket, and this should be equal to 1. Okay? We are running smooth because we know the concepts on how to simplify. Okay? So minus 3. What do we do of all the terms inside? Algebra. Okay? Try to combine similar terms. 2x minus x will be x, and 10y plus y will be 11y, close bracket, and this should be equal to 1. What's next? Expand. According to the rule, expand. Why expand? Because there is a bracket. We must have to multiply, right? Negative 3 times x will be negative 3x, negative 3 times 11y will be negative 33y, and this should be equal to 1. Okay? We are solving for y as a function of x. I will now try to write the y term firstly. Okay, so this is negative 3y. I will write negative 3x. And I want this negative 3x to be banished from the left hand side. So I will add up plus 3x. Okay, and this should be equal to 1. Okay, I add up 3x on the left, I will add up 3x on the right, right? So it doesn't change the value. And the purpose of adding this one is to eliminate x on the left hand side. So this one cancels, right? Negative 33y, I will try to rearrange this one. I will write x term first, so this 3x plus 1. We are to solve for y without the negative 33. To eliminate negative 33, we divide both sides of the equation by negative 33. Negative 33y over negative 33 should be equal to 3x plus 1 over negative 33. Negative 33 cancels. Okay? Y now, it will now just be simply 1, the left hand side, y. It is isolated on the left hand side, right? Y equal to. Okay, we can make it like this to look handsomer, right? So this is negative 1 over 33, okay, times the quantity 3x plus 1, close quantity, and that will be the answer. As simple as that one, as long as you know the concepts on how to simplify from the fundamental operations. Okay, good evening from Los Angeles. This is Professor David J.